everyone. In the previous video, we saw the importance of graphical representation of data. We started with the bar graph on which we represented categorical data. But what if we are given data that is non-categorical? Or in simple words, in the form of continuous class intervals? Well, to represent such data, we use histograms. You are familiar with them, right? Yes, you studied them in class 8. But why are we studying them again? Well, there is more to histogram than meets the eye. Histograms are very similar to bar graphs. They are drawn practically the same way as bar graphs, but with a few key differences. Let's draw one to understand. Say, we are provided with the ages of students joining a swimming class. Clearly, the data is grouped and the classes are continuous. So, to draw a histogram for the same, we follow the similar steps as we did in the case of a bar graph. Firstly, the horizontal and vertical lines are drawn, meeting at a common point. Then, a suitable scale is chosen for the horizontal line to represent the class limits. Since the class size is 2, we can choose a scale of 1 cm as 2 years. So, draw the markings from 9 to 19 according to the classes. Since the lowest limit is 9 and the class size is 2, a kink is drawn to show that the age groups between 0 and 9 are not being represented. But what if we have intervals like 10 to 20, 20 to 30, 30 to 40 and so on? Do we still need to mark a kink? No, because here the lowest limit and the class size are the same. Both are 10. So do you realize when we put a kink? Yes, we put a kink when the lowest limit is not equal to the class size. Now, a second scale is chosen for the vertical line to represent the frequencies. I will take 1 cm is equal to 2 students as the scale. Now, just like in bar graphs, we draw rectangular bars of width equal to the class size and length equal to the corresponding frequencies. So let's represent the frequency 12 in the class 9 to 11. Now let's represent the frequency 10 in the class 11 to 13. Now here comes the key difference. The bars in histogram are continuous. There is no gap between them. And why? Because here the intervals are continuous. That is, because of this common point here which appears in both the classes. So, continuing the same way, we get the histogram which represents this data graphically. Looking at the histogram for this data and the bar graph for the previous one, we may say that both of them look similar. But it is important to understand the differences. Bar graphs are used to represent ungrouped data that are spread over categories, whereas histograms are used to represent group frequency distribution with continuous classes, which is why the bars in bar graphs are equally spaced. But in histograms, there is no space between the bars, so as to accurately represent the continuity of the dataset. There is one more important fact about histograms. Want to know? Catch me in the next video. Now, let's do a quick recap. Histogram is a graphical representation of a group frequency distribution with continuous classes. Rectangular bars are drawn on one axis depicting the classes. The frequencies of these classes are shown on the other axis. The bars in histogram are continuous. That is, there is no space between them. A kink is a jagged line that is used to represent empty groups between 0 and the first group. In other words, a kink signifies that the class interval from 0 until the lower class limit of the first group have no data or frequency. They can also be used on the vertical line to show a jump from 0 to the smallest frequency.